You watched the video, you bought the materials, you cleared your Saturday morning, and you are absolutely convinced that you can handle this repair yourself. But here is what that YouTube tutorial did not tell you. The home you are trying to fix is not the same kind of home that tutorial was made for. Modern American construction has become so technically complex, so deeply integrated with proprietary systems, engineered materials, and code-dependent assemblies, that the gap between what a homeowner can do and what a homeowner thinks they can do has never been wider in the history of this country. And the financial consequences of getting it wrong are not a bad patch job you repaint on Sunday. We are talking voided warranties, failed inspections, insurance claim denials, and structural damage that compounds silently inside your walls for years before it announces itself with a repair bill that will make your stomach drop. I am Engineer Vance, licensed forensic structural engineer. I have spent over 2 decades being called in after the DIY repair went wrong, and today I am going to explain, from an engineering standpoint, exactly why modern homes have outgrown the DIY model, and what it costs American homeowners every single year when they do not understand that reality. To understand why DIY repair is collapsing, you have to understand how dramatically residential construction technology shifted between 1980 and today. The home your grandfather built, or the one your parents bought in 1972, was constructed with dimensional lumber, real 2x4s that actually measured 2 inches by 4 inches, simple copper plumbing, standard fiberglass insulation, and gravity-fed systems that a mechanically inclined person could genuinely understand, diagnose, and repair with basic tools. The modern American home is an entirely different organism. Structural framing now relies heavily on engineered lumber systems, laminated veneer lumber, parallel strand lumber, wood I-joists, and oriented strand board sheathing, all of which have specific load ratings, connection requirements, and failure modes that are categorically different from dimensional lumber. These products are governed by ICC ESR reports and must be installed per manufacturer specifications that are legally binding under IBC Section 1901 and IRC Section R3001. Modern electrical systems now require arc fault circuit interrupter protection in virtually every room under NEC 2020, Article 210.12. Modern plumbing systems use PEX A, PEX B, and CPVC assemblies with expansion fittings, and manifold systems that require specific tools and calibrated torque. Modern HVAC systems are variable speed, communicating systems with proprietary diagnostic software that a standard homeowner cannot access without a licensed technician's credentials. Modern building envelopes use spray polyurethane foam insulation that creates an unvented conditioned attic assembly, a fundamentally different moisture dynamic than the ventilated assemblies that every old DIY handbook was written for. Every one of these systems has a specific engineered repair methodology, and when you substitute a YouTube tutorial for that methodology, you are not just risking a bad repair, you are potentially compromising an integrated building system in ways that will not be visible for months or years. Here is the engineering reality that most homeowners fundamentally do not grasp. A modern home is not a collection of independent systems. It is an integrated building assembly where every system affects the performance of every other system. This is the core reason DIY repair fails so catastrophically in modern construction. Let me give you a specific example using building science. A modern code-compliant exterior wall assembly in a mixed humid climate, states like Virginia, Tennessee, North Carolina, and Missouri, is designed as a specific moisture management system. The exterior has a drainage plane. The sheathing has a specific vapor permeability rating. The insulation has a specific R value and vapor retarder class. The interior drywall may have a smart vapor retarder. Every single layer in that assembly is engineered to manage moisture vapor drive in a specific direction at a specific rate, per ASHRAE 160 moisture design criteria and IRC section R702. When a homeowner cuts into that wall to repair a window, installs a new outlet, or patches a section of drywall, and then reassembles that wall using materials and methods that are not compatible with the original assembly design, they have just created a moisture trap. Vapor now accumulates in a layer of the assembly that was never designed to manage it. Over 18 to 36 months, that accumulated moisture produces mold growth inside the wall cavity, degrades the structural capacity of the OSB sheathing, and begins attacking the bottom plate of the stud wall at the sill level, one of the most structurally critical connections in your entire framing system. The IBC and IRC do not just specify what materials to use, they specify how those materials interact as an assembly. A code-compliant repair is not just about matching the surface finish, it is about restoring the engineered performance of the entire assembly at that location. That is a building science discipline, not a weekend project. Let me walk you through a forensic investigation I conducted in the Ballantyne area of Charlotte, North Carolina in 2022, because this case is a textbook illustration of how a well-intentioned DIY repair cascades into a six-figure structural remediation. The homeowner had noticed a soft spot in the hardwood floor adjacent to the master bathroom, along with a slight discoloration in the grout line at the shower threshold. He watched 3 tutorials online, determined it was likely a failed shower pan, purchased a sheet membrane waterproofing kit from a big box store, and spent 2 weekends removing the tile, installing the membrane, and retiling the shower floor. The finished product looked excellent. He was genuinely proud of it. 14 months later, his real estate agent called to tell him the buyer's inspector had flagged a structural concern during the sale inspection. I was brought in for the forensic evaluation. What I found under that beautiful tile work was a cascading failure that the surface repair had completely concealed and actively accelerated. Here are my documented findings. The original shower pan failure had allowed water to migrate beneath the mortar bed and penetrate the plywood subfloor below. A 3/4-inch tongue-and-groove plywood panel that had been absorbing moisture for an estimated 24 to 36 months before the DIY repair was even attempted. That subfloor panel had lost approximately 60% of its structural capacity at the wet zone. The homeowner's membrane installation had used a sheet membrane system that required a specific primer and bonding mortar per the manufacturer's ICC ESR report. The homeowner had substituted a standard thin-set mortar without the primer. The membrane had debonded from the substrate along approximately 40% of its surface area, creating a void space between the membrane and the mortar bed that was actively trapping moisture rather than managing it. And here is where the situation became genuinely dangerous. The moisture that continued migrating through that debonded membrane had now reached the engineered I-joist directly below the shower floor. That 12-inch engineered wood I-joist had experienced OSB web degradation over approximately a 30-inch length. Engineered I-joists, unlike dimensional lumber, experience sudden and catastrophic web buckling failure when their OSB web is moisture compromised. There was no visible deflection from below. There was no audible creak from the floor. The joist was simply losing structural capacity silently, invisibly, every single day that passed. The remediation scope included full shower demolition and assembly replacement with a code-compliant sloped mortar bed and sheet membrane system at $8,900, subfloor replacement over the affected zone at $4,200, engineered I-joist repair using manufacturer-approved structural repair plates and sister framing per the ICC ESR repair protocol at $6,300, and mold remediation of the cavity per IICRC S520 protocol at $5,500. Total remediation cost, $25,900. The original shower pan repair, done correctly by a licensed tile contractor from the beginning, would have cost between $3,500 and $5,500. The DIY attempt cost this homeowner an additional $20,000 and nearly killed his real estate transaction entirely. So let me give you the definitive breakdown of modern home systems, where DIY intervention consistently produces documented engineering failures, and explain precisely why each one is beyond the DIY threshold in 2024. Structural framing repairs involving engineered lumber are the first category you must never touch without professional guidance. Engineered lumber products, LVL beams, I-joists, and PSL columns cannot be field-modified, notched, or repaired using conventional lumber repair methods. Every penetration, bearing condition, and connection for these products must comply with the manufacturer's ICC ESR report. A field repair that violates those specifications is a structural defect under IBC Section 1604, regardless of how structurally solid it appears to the untrained eye. Exterior wall assembly repairs are the second category. Any repair that involves opening the building envelope, replacing sheathing, installing new windows or doors, or modifying insulation must restore the full moisture management performance of the original assembly. This requires knowledge of vapor retarder classes under IRC R702, drainage plane continuity requirements, and climate zone-specific material selections per IECC Table R402. Getting any one of those variables wrong creates a moisture accumulation condition that destroys your wall from the inside out over the next 2 to 3 years. Spray polyurethane foam insulation is the third category, and it is one of the most frequently misunderstood products in residential construction today. SPF is a two-component chemical system requiring licensed installer certification in most states. Improperly mixed or applied SPF can off-gas toxic isocyanate compounds for weeks after application, create unintended vapor barriers that trap moisture in adjacent assemblies, and compromise fire-rating assemblies in ways that create serious life safety violations. It is not a caulk substitute, and it is not a DIY product in any meaningful or responsible sense. Shower and wet area waterproofing is the fourth category, as our Charlotte case study demonstrated with painful financial precision. Modern waterproofing assemblies are engineered systems with specific substrate preparation requirements, bonding agent specifications, and cure time protocols that are non-negotiable. Substituting materials or skipping primer steps does not produce a slightly inferior result. It voids the system performance entirely, and the failure mode is always hidden, always slow, and always exponentially more expensive than the original repair would have been. Electrical panel work and circuit additions are the fifth and final category I want to address today. Beyond the obvious and well-documented safety issues, modern NEC code requires AFCI protection on new or modified circuits in virtually every living space under Article 210.12. A DIY circuit addition that does not include AFCI protection is a code violation that will fail any future inspection, void your homeowner's insurance coverage for any fire originating in that circuit, and become a mandatory disclosed defect in every future real estate transaction involving that property. The answer to all of this is not that you are helpless in your own home. The answer is that the role of the informed modern homeowner has fundamentally shifted from doer to informed director. Before you attempt any repair, identify exactly what building system you are working with. Is that wall an exterior assembly or an interior partition? Is that framing dimensional lumber or engineered lumber? Is that insulation fiberglass batts or closed cell spray foam? Is that plumbing copper, CPVC, PEX A, or PEX B? The repair methodology is completely different for each one. Then, before you open a single wall or drill a single hole, invest in a pre-repair consultation with a licensed professional. Not a contractor quote, a consultation. Many licensed structural engineers, building envelope consultants, and master plumbers offer diagnostic consultations for between $150 and $400. In that consultation, a licensed professional tells you exactly what system you are dealing with, what the code-compliant repair methodology requires, and precisely which components of that repair are within a skilled homeowner's capability and which are not. That $200 consultation is the most valuable investment you will make on any repair project, because it is the only thing standing between a manageable repair cost and a $25,000 remediation. And always, always pull the permit before the work begins. A permitted repair is inspected by your local authority having jurisdiction, which means a licensed inspector verifies code compliance at critical stages of the work. That inspection is free quality control that simultaneously protects your manufacturer warranty, your homeowner's insurance coverage, and your property's resale value. The DIY culture in this country was built on a legitimate and honorable tradition of self-sufficiency, but the homes being built and sold in America today are fundamentally different machines than the homes that tradition was built around. The complexity has increased, the integration has deepened, the code requirements have expanded significantly, and the cost of a failed repair in a modern home is not an afternoon of frustration. It is tens of thousands of dollars in remediation, a voided warranty, a denied insurance claim, and a disclosed defect that follows that property through every future real estate transaction. Be the informed homeowner, know your systems, consult before you cut, pull the permit, and understand that in 2024, the smartest DIY decision you can make is knowing precisely when not to DIY. I am Engineer Vance. Protect your structure, protect your investment.